We have the results here. It's 69% for 1 to 10 million, and we have 15% for 10 to 20 million, and we have 8% to 20% for 50 million and above.
Okay. Thank you very much for answering that. Many a times we have seen that maintenance managers have a hard time coming up with the figure because many a times this kind of information is stored in different systems, and then just there is not enough sense of what's the total inventory. Some companies are very good at it. Some companies kind of have an idea, but because of various issues with the financial system, it may get depreciated, or it may get different business rules are applied when valuation of the spare parts is done. And it becomes a little blur because of different business rules. But essentially, the idea here was to kind of understand how big the problem is in certain companies versus another company, and it can put things in perspective. So there are many challenges in spare parts management we all have to deal with on a day-to-day basis. And overarching thing that we all are goal that we all have is to how do you optimize the spare parts inventory. You want to get in the context of maintenance and reliability objectives, we got to find how we can optimize it. And getting timely alerts on crucial issues and events and how it relates to spares, monitoring cycle counts, spillage, some other performance-related goals. So various things that we all have to deal with on a day-to-day basis on a spare parts management. Before I go further, I have another question, polling question.
All right, your second question today is, what CMMS software do you use? Option 1, SAP. Option 2, Maximo, DataStream, Oracle, or other. The result for the poll is it's 7% for SAP, 43% for Maximo, 14% for DataStream, 36% for other.
Okay, great. So the fact that there are companies who are already managing spares as part of CMMS is always a good thing, because then everything can be put into single place and can be brought together from a data analysis and reporting perspective. So as all of us are kind of always dealing with this spare parts cost versus availability, how do you strike a balance, and what are the decision process that we all have to go through? On one hand, we have to deal with the understocked or we may have an overstock. So how do you actually balance it out? So you don't want to have a situation where it affects your the failure cannot be addressed or machine cannot be repaired because of lack of spares, and it leads into production loss, or in some cases internal customer or external customer dissatisfaction. And the other side is, of course, if you can always overstock, and as a security and as an insurance policy, you can always overstock. And but the flip side of that is your inventory carrying cost is going to add to the overall maintenance budget, and it will have adverse impact. So we all deal with this. Is always a balancing act. How do you decide, when to and what to store? And there are a lot of maintenance strategies, spare parts strategies, and there are people specialize in how the spare parts should be handled. How do you assign criticality? How do you assign various levels of min, max, etc. So our focus in this presentation is more to deal with not necessarily the mechanics of spare parts management, but more to do with how do we handle our day-to-day job, whether it is maintenance manager, whether it is inventory control manager or storekeeper, or anybody who is dealing on those things, or even procurement in some cases. So we are going to focus more on to the data analysis part that is related to various job functions, and not necessarily on how to exactly tag it, spares, or how needs to be stored in different storerooms. I mean, some of those things we are not going to touch on in today's conversation. So, but again, we all have to deal with these conflicting pressures. So the overall goal in most companies will be is to minimize the cost or optimize the overall cost associated with spares management. So this is a classic curve, nothing different about it, but actually achieving that in the real world is the real challenge. We have seen many companies struggle with that because of various dysfunctional, conflicting issues to manage spares. So, but ultimately this is our goal, and even if we are close in this middle circle somewhere, I think we will be in a good shape. So let's look at some of the options where data analysis can help everyone involved in spare parts management, as well as people who are actually requesting for spares. We all want minimum stockouts. We want shortages. We want to minimize the events associated with stockouts or shortages. Ideally, you don't want any stockouts. We want adequate control over materials used and unused. Many companies will have situation, people will have trucks, and they will take it onto the trucks, and then that inventory count is almost lost. Or in some cases, there will be a local storage. There will be a central storeroom, but there is also going to be something at a department level or something that people will issue it and then not return it. So there are a lot of details that go with it, which can be highlighted with the help of data analysis. Sometimes, how do you select what spares to store and what not to store? So how do you look at, based on the lead times that you might have, or the shipping cost that is associated with it? Or sometimes you have too much rush deliveries of, so you can do analysis, okay, how much did we spend on the rush deliveries? We have seen issues to identify whether you have duplicate item masters or duplicate, and hence there is no relationship, or you're not able to get a good picture of the inventory level. You can also find with data analysis where to focus your spare parts related adjustments and process changes. Where can you focus your energies in terms of, so you can actually, data analysis can help you. You can reduce the overall inventory carrying cost, and associated with your business goals. You can forecast what the future requirement might be based on your historic data and your future plans for all related to PM activities, and you can also forecast future failures based on, and then forecast your overall requirement based on these two factors as well. You can formulate your control policies based on different categories of spares. Actually, you can categorize based on the various data analysis options that, and we'll discuss that in our discussion today. You can also look at the capital versus rotating spares, spares which are, how do you do inspections, cycle counts, obsolescence. So those are detail level work also data analysis can assist you with. Many organizations we have seen struggle with spare parts data analysis for various reasons, and first and foremost is lack of understanding of how data can be leveraged. Sometimes IT has some limitations because spare parts may be stored in some other ERP system and CMMS system is a separate system and there is no connection, or there is a limited connection and data is not easily available. The biggest problem we have seen is the poor data quality in terms of accuracy, consistency, completeness, integrity, etc. And just you cannot trust data analysis. This is just an example of a company which had 5 to 10% duplicate material master, 16% of materials unknown usage. It is just there into the system, but there is no clear-cut understanding of the usage. The only 44% in this, again, this is a case study of one company where 44% was the only unique spares. Rest all were duplicates or suspect in terms of item master. 38% had equipment with no bill of material assigned to it. So it was just, there is no direct association of spares with a particular asset. So there are different areas one can analyze. The other issue we have seen why people don't rely as much is because most of the decisions are based on experience and hunch, and it's not necessarily based on data-driven itself. And leadership is not insisting the middle-level managers and lower level in the rank to use data as a management tool rather than something that is done only for executives. So we have seen the cultural aspect is very, very important along with the data quality. Some information gaps in the standard CMMS that we get. Most of the CMMS is designed for operational type of reporting and data analysis, and not necessarily ad hoc reporting is not feasible easily. Then sometimes if you have spares managed data is in some other data sources like a ERP, then you need to combine that from a reporting standpoint. Then you have some limited KPIs, dashboards, scorecards. So we find most of the standard CMMS are not designed to be data analysis tools. They capture all the data, all transaction data, but not necessarily allow you to do advanced level of data analysis. So before I go further, I have one more question, Neil.
Yes. What software do you use for managing spare parts? SAP, Maximo, DataStream, Oracle, other? The results are 15% SAP, 40% Maximo, 15% DataStream, 25% other, and it's 5% for Oracle.
Good. So seems like most of the people are using the CMMS system itself to manage spares, which really, really helps in terms of how this data can be used. You can link everything to the work orders as well as to the assets much easier when you have an integrated system. So I think most of the attendees seems like in a better shape than what we have seen it in the past surveys for a question like that. So broadly, the data analysis can be used from demand analysis itself. So you can look at the past trends, what your current requirements are in the near future, what the requirements are, and then you can actually do a future forecast, which is for, maybe 12 months to 24 month cycles or 36-month cycle, depending on how your culture is. But typically, it will be 12 to 24 month cycle when you are trying to plan something. If sometimes you have a turnaround or shutdown type of events, and for which you may plan well in advance, then it also helps. So we can talk about how it helps the procurement planning. The demand analysis and procurement planning will usually go together. and then how data analysis, the other areas is inventory control, and how the stores are managed, how do you do inspection, audits, etc. So again, a lot of this can also be divided based on the job function itself. If I'm a inventory manager, then I have a certain responsibilities, and we can actually look at from that angle as well. So he might be involved more onto the inventory control side of the equation, and somebody who is doing stores management may be involved in. So a lot of times we have seen job and data analysis. If we try to map it, it will be a lot easier. So before I go further, I have another polling question.
Yes. Which reporting tool do you currently use? BIRD, Business Objects, Crystal, Cognos, Microsoft Reporting Services, other. The results are 24% BIRD, 18% Business Objects Crystal, 22% Cognos, and it's 11% Microsoft Reporting Services, and 26% for other.
So most of the companies which are using these industry standard tools, there is a lot of options that will allow them to do variety of reporting, whether it is simple operational reporting, or if you are doing some sort of dashboard metrics, or in some cases it seems some tools will allow you to do forecasting and more statistical analysis as well. So the tools have some level of impact on what kind of analysis you might be able to do. And that will actually, the combination of data quality, the systems that you use, and the tools that you use gives you a good platform so that you can build necessary programs to do data analysis. So good to know that most of you all are using industry standard tools. So some examples that we are going to go through is fast, slow-moving, non-moving type of spares, ABC analysis. We'll talk about VED, etc. So let me go to the actual example itself. Let's first get to the definitions of some of these analysis. Why do we do it, and what's the purpose of this type of analysis? If we have 20,000 items, or 200,000 items, or just 10,000 items, depending on the industry that you deal with, or you are in, or the kind of maintenance activities that you do, you can always categorize based on fast-moving, slow-moving, non-moving, and these are, you can determine what you mean by fast-moving. There are some industry standards, but you can also define your own velocity of this usage of a particular item. Is it used 10 times a month or 20 times a quarter, however you want to define it, but that actually gives you an idea what spares are frequently used and what is not frequently used. That's the purpose of this. And all of these things can be analyzed if you can run a program that will actually, based on your business rules on how you want to calculate this frequency, you can tag each one of these items based on this FSN analysis. And when you put everything into perspective, it will give you a different picture, and it will help you determine what you should carry and what you should not carry and all that. It also kind of leads into your criticality analysis as well. Another way people do is based on the consumption, which again relates to the FSN analysis, but it's a little bit different. It takes into account overall consumption for the whole year, for the quarter, for various time intervals. You can do this type of analysis. each company, and this is just one example, each company has various ways you can actually define based on the value or based on the item counts also you can go about doing the ABC analysis. Another, just from an ABC analysis, there are some policies, decisions you have to do before you actually do this type of analysis. It could be whether you want maximum control, value, supplier, all different ways you can actually categorize it further, or you can actually decide on the bulk orders, etc., based on your suppliers. Another analysis people do is really determine from availability of those spares itself. Is it scarce to find these spares? Is it difficult to procure this? It takes longer lead time, or is it easily available in the open market? You can go to Home Depot or go to Lowe's or some, that's just an example, but there are a lot of online companies providing spares too. So you can actually determine, based on this, you can determine and categorize your spares. And this is more subjective. It is not necessarily based on data, but assuming that you have entered all the lead times in each of these spares, you can then categorize and create rules around what should be treated as scarce, difficult, and easily available. Same thing, this also leads to criticality analysis. What would you consider as a vital spares? What are essential and what are desirable? This again it's more qualitative. The criticality itself can be actually mathematically associated with the spares based on the downtime or criticality of your assets themselves, and all the spares that were used in those assets in last 3 years or 5 years, you can then mathematically assign criticality to the spares also. So, and that then can be further qualitatively evaluated by individual managers or reliability engineers or however you are organized. But the idea here is to identify all the spares that are consumed by the critical assets over the last 3 to 5 years, and then essentially assign or tag all these assets. All these different ways of tagging will actually give you a good picture on each individual items within your spare masters. Another way people do is you can tag based on the unit price of that particular spare, which could be very, very highly expensive spare, and you may have very few of those, but again, those are expensive, very high cost per unit. And then it's your decision to how you want to categorize as what is medium to you versus what is low and what is consumable. So that's another way you can categorize. There's another way people categorize is lead time, which also goes to our previous conversation around vital and SDE, scarce and lead time actually go together. But you can have a various, based on your demand and the experience of the lead time, how you negotiate with your suppliers, vendors, you can actually determine the lead time. And many a times companies have started allowing the third parties to provide it on demand type of 24-hour cycle for providing spares. So in that case, you may not carry these spares and somebody else carries it and you just request it. So there are different management options, procurement options many companies follow, but this kind of gives you what you should consider. You can actually tag based on historic data what the demand was. Was it smooth? Was it slow moving, erratic? And this can be mathematically in the reporting can be done to determine whether it was a smooth demand or not. Just to calculate basic min-max, many a times we have seen companies just put min-max at the time when the spares were added into the system, and they rarely go back and review the min-max levels. But if you have a good analysis, it can periodically look at your min-max and help you readjust your min-max levels. This is a simple calculations of how the minimum stock level can be calculated, and this is a well-known industry standard. There's nothing new about it, but the idea here is the data analysis can go back and look at last 3 years or 2 years or however, whatever the time frame that you want to look at, and determine these min-max levels for each individual items and this you can do it at even at a department level if that's the way you want to do it, or at a company level, or at a site level, depending however you want to run this. But you can build this min-max levels for each one of the items at individual locations also. And once you do that, it would, and a report can be generated, and then allow your reliability engineers or allow your spare parts manager or a maintenance manager to actually adjust the min-max based on their experience and the values that are provided by this data analysis. So I think that kind of helps the managers to look at various min-max factors. The other factors to consider as far as inventory carrying cost is concerned is the storing and the storage related costs. Most of you may have internal storage, so there is no rent, but if you have to allocate certain costs towards storing these, so there are different factors to consider: depreciation, handling charges, etc. And then cost of ordering itself can be included. Then there are other costs associated with it as well, where the particular spare may be obsolete or may become obsolete, or there is a time dependency on that. So there are other costs to be considered, and all these costs can be done at an individual item itself and can determine what your carrying cost is, and that will help you determine how you can come up with a economic order quantity, or what should be the actual inventory carrying cost for the entire inventory that you might have. So earlier question that we had was more on what's your inventory cost. That was mainly, I'm assuming that it was done at a very high level, but when you get into these details, the inventory carrying cost will be way more than what the book value will ever show you. It usually, we have seen when you do a detail exercise, it may go up to almost 20% higher than what it is showing on the books. So before I move forward, I have another polling question.
Yes. How will you rate your spare parts data analysis practices and maturity? Your options are excellent, good, poor, very poor. The results are 0% for excellent, 26% good, 53% poor, and 21% very poor.
Okay, so overwhelming, people consider that they have a less of availability of good data or the reporting or analysis capabilities at this stage. So as we go further, let's look at some of these examples, and we can then look at maybe you can reevaluate your own assessment. Some direct problems that maybe data analysis can help, which a transaction system may not be able to. As we discussed, if you want to determine a probability of a stock out, you can use certain statistical techniques like Weibull analysis or some other ways by which you can actually determine what your stockout risk is and how it relates to your downtime risk and how it relates to your reliability goals. So some of these analysis can be done only by data analysis. In the whole procurement process itself, in the supply chain process, there will be certain bottlenecks, your internal processes that you are, or workflow that you might have. And Six Sigma or a similar analysis like that can actually allow you to determine what your bottlenecks are. And most of us have systems, processes, and people are trained on this, but some of these processes need as a part of continuous improvement process, you would like to identify the bottlenecks, and these are the data analysis can actually help you with that itself, that identifying the bottlenecks itself. You can also understand your procurement efficiency, the whole cycle of procurement, vendor analysis, whereby you can determine effectiveness of the supply chain and the vendors associated in that supply chain. How do you optimize the stock holding? Rush shipping charges. Many companies have outsourced their spare parts supply, and in that case, many a times they are incurring a lot of cost associated with rush shipping. We had one example where the more than $2 million was spent over the just on FedEx and UPS related rush shipping. So in the beginning it may not be visible, but when you do an analysis on just shipping cost, because you are not storing it, so there is going to be a balance that you have to strike where to store it or spend a lot of money on just shipping charges. And then there are other events or other types of spare. It's very erratic. You might use something every 2 years or 3 years. And how do you really determine what should be the level of stocks that you would like to have? And again, statistical analysis can help you towards that. And after that, obviously, it's going to be some decisions based on reliability engineering group or management, maintenance management group will have to decide. But these type of analysis can be helpful. We will show some examples on how to identify slow-moving or non-moving items. Cost for most of us have to kind of go through budgeting process early in the year or the previous year. In that case, data analysis can kind of project what would be a budgeted cost. Many a times, many companies will just use the previous year's budgets and then just maybe add 10% or things like that. But I think it would be useful to actually do some analysis and figure out what your projected maintenance or preventive maintenance program is, and the type of work orders you might have, and what the related spares you might require. And on the failure side, you can go back in the historic data and look at what the pattern of failures were and what the usage of the spares was. So again, some of this analysis only can be done with the help of data analysis. So some other examples related to scorecards and performance management related. So this is just an example. This is a balanced scorecard example where how it relates or how it can be linked with spare parts management. So there are various aspects. Each one of these boxes can lead to and find out whether there is a direct relationship with the spare parts or not. So this could be part of your overall asset performance management goal, and then you got to figure out how spares management fit into this particular strategy map. A similar example can be, you may not be able to read, but again, this is just example at a very high level what the corporate goals are, what the leading indicators are, and what the lagging indicators are, and how does spares fit into all these mix. Some examples related to that. But most companies at a broad level, and it will really depend on the industry that you are dealing with, but we just have to find these three things that a lot of companies kind of take that into account as MRO service levels, inventory turns per year, These are figures that at the industry level people have been talking about, and the overall value of MRO with respect to your equipment replacement value. So again, this will vary from industry to industry, company to company, but I just wanted to give you and kind of what some of the experts would like to see it if they have to trim it down and look at the world class, how that would look like. Some other KPI examples, and I'll show some more details one, but this is more related to spares itself. So I'm not going to go into each one of these details. This slides deck will be available on the Asset Analytics website for you to look at it. So I'm just going to go through because there is but whenever you define a KPI, you should have a strategic objective. Try to find what the goal you want to have, what the targets you want to have, and how you would like to measure it, and put this into context of the strategy map that that I was sharing with you earlier. Some demand-related things that kind of can help. This is a very simple analysis. You can kind of tag it on what is smooth, what is irregular. So these are some of the rules that you can, an example of how these rules can be defined. What is slow-moving, what is mildly erratic, highly erratic, and all these things. You may have only 3 categories. You may have 4, depending on how you want to, and you may further do it for certain type of spares, and you might handle critical spares differently than all other spares. So there's a lot of strategy around it, and the purpose of our conversation today is not so much on what should be the strategy, but so much on what kind of data analysis will help you build your strategy, monitor the execution of that strategy, as well as monitor the outcomes of the strategy so you can realign your actions, etc. So sometimes people will further do analysis, what is mean, max, standard deviation. So it kind of gives you some sense of price also of the spares and how it relates directly with the overall decisions that you have to make related to supply chain, related to vendors, all the procurement process, etc. Some based on demand, again I'll show some other examples also, but you can actually, when you visualize it, you may get a different level of understanding of your spares. So let's look at some examples that may give you an idea about various. So before I start, this is just as an example. We were talking about what should be the MRO service level. This is just one KPI. So at your company level, you can define these as a standard KPI. So there is a, and that is used across all your company, various sites, various locations, etc. So different ways these KPIs can be defined. Objectives, what goes into that KPI, how do you calculate it. There's example of a simple calculations, etc. Same thing, you can do it on inventory turn. So this type of definition and standardization of KPIs will allow you to have apples to apples comparisons, and that's really the purpose of it. And well-documented KPIs will go a long ways in terms of removing all the ambiguity. So let's look at some examples related to, let's say, FSN analysis. So this is fast-moving, slow-moving. So based on certain rules, you can classify all your item master and what was the average stay, what is the cumulative average, all that percentage, and then you can assign or tag a particular item. So this is just as an example of that. Let's look at how do we calculate economic order quantity. By the way, whatever I'm showing you, these are PDF files. This is not actually running a particular program for just to ensure that this presentation is fast. I'm just kind of showing you the output. So there are a lot of assumptions when you calculate economic order quantity. You can take into account various factors, and I have some other examples also, but really the calculation behind the scene, how each item is evaluated, is based on various costs, annual holding cost, purchasing cost, and then arriving at a total cost, what would be an economic order quantity. So mathematically, you can identify, you can calculate it and then decide what is practically feasible as far as your economic order quantity might be. Sometimes there are good statistical techniques will allow you to forecast your erratic demand. So this is just as an example. But this again has to put in context with your criticality of the spares. So there are a lot of analysis that has to be done beforehand, and then kind of augment that. In that decision process, you can augment with this type of analysis. And what we have seen is the combination of the information will actually help you make more informed decisions. So it's not a single report or a single analysis alone will tell you. This is another method of doing forecasting the demand, and that's called. So there are various models statistically, and each model has its own advantages, disadvantages, etc. But essentially, it kind of gives you various options on calculating, and this is more statistical in nature. Everybody doesn't have to know, but essentially, what they are trying to find is there is a science behind how this the demand is forecasted. Let's look at another example on how do you relate demand with, or the stock level with actually reliability goals. So in this, so there is a analysis that goes into reliability, and so here in this example, you can kind of see based on your reliability goal, if it is 100%, what should be the level of stocks and how it impacts the reliability itself. So you may come up with, instead of storing 100 units of a particular item, maybe you will have same level of reliability by storing maybe 60 units, and maybe you have some insurance stock and you may arrive at a 70 or 80 units as an optimum. So again, in such a analysis, these type of reliability goals and kind of associating it with the spares stocks, you can actually determine what should be an ideal stock, an optimum stock level. The tools and technologies have become a lot more sophisticated. So now this is an example where you can actually do what-if analysis. So for one particular site, you can, this is just as an example, you can look at a store and look at a particular item. Once you look at an item, what it is really trying to show is previous year what these costs were, demand per year, fixed costs, unit handling cost, all these different costs. And it allows you to actually, on the right side, actually it is calculating based on your forecasted PM activity as well as forecasted failure. It is taking into account what should be the level of stock or what might be the demand for that particular spare. And then you also can look at what was your trailing 12 months demand itself. So it kind of gives you both picture here. What is the forecasted demand as well as what is the trailing demand. And then on the right side, it is just plotting what the per month. So if I change the fixed cost by 10%, you can actually look at what your variable cost is. Or if I change my unit cost or your item cost changes, how it will impact the overall inventory carrying cost. So this type of analysis or a calculator will allow you to kind of do what-if scenarios. Some of these scenarios you can store it and then do future, come back to that analysis again. And if you negotiate better terms with your supplier and lead time is reduced, how does it impact your economic order quantity? If you want to, maybe some spares you want to take less risk than the others. So in that case, how does that EOQ changes? So this type of tools it will become very, very helpful for reliability engineers and procurement department to actually look at what the EOQ is. Let's look at some other analysis itself. This can be a kind of a dashboard which allows you to show what your top 10 assets by count, and then maybe you will include rotating assets as well as part of your spares. So you can actually get visibility across some of the high value or highly used assets within the, or highly used spares within the department, within the site, across the enterprise. However you want to slice this data. You can do it for cost, maybe based on your shortages, that type of thing. Let's look at some other examples here. Usage, of course, there is a graphical version, and this is a boring, more detailed type of version, but essentially the idea I wanted to share was from that graphical version you can actually come to a version like this of an analysis where it will show you the whole history of the usage itself of different spares. Some part shortages type of report which will allow you might review this every quarter, every 6 months, what the shortages were, and maybe look at the procurement process and supply chain, how you want to readjust some of the processes around that. Reorder point, again, simple. This can be color coded, and you can drive this type of report can be sent out to the vendors, or for, of course, each specific vendor you can run it and automate this process. Most of the CMMS will allow you to do it. And the idea here is as much decisions you allow data analysis to make, it will help you manage your inventory better. Some other examples on inventory turns, and let's look at, in the interest of time, let's look at some storeroom related report. You can actually do facility by stock. You can do valuation of each store and look at what are your opportunities to reduce the overall inventory itself in context with all these other factors that we discussed. Some other KPIs, issues versus receipts, net issues per month. So this kind of allows you to look at how the storeroom activity is and what level of changes you might have to do it at the store level, so they work more efficiently. And if some companies are working with kitting as a process where for each work order they may kit all the spares related to that, so that also helps storeroom efficiency and some labels, and so you can actually create all these kits beforehand, so there is a very quick way of providing all the items or all the spares related to a particular work order. Sometimes a lot of in the kitting, people take stuff but may not use it, so it's good to kind of have a report which helps you find the return items as well. Again, let's look at some other. If you are using consignment, most companies are also looking at consignment as an option. You can actually create liability related to consignment. So as and when you use it, and you might bill it every month or every quarter, however your commercial terms are, but it kind of gives you what your liability is, and most ERP system will calculate all, or CMMS system will allow, but it will also give your suppliers the opportunity to actually look at how to restock it, etc. So now let's look at the inspection itself. A lot of times many companies go through spare parts inspection process. So if you're doing unique cycle count, and the missed cycles, or however you are running your inspection program, data analysis can help you, assist you with that whole process. The unique cycle counts you can do across different groups, different storerooms, and then identify various areas that you need to revisit if you have missed certain cycle count at all. So there are a lot of, after the inspection is done, you can do variance reporting, and if there are significant variance, maybe you can create some alerts and create certain exception reporting, which can then be escalated within the group, especially for high value items. So you can create certain rules, business rules, and data analysis can be done so that certain events can be escalated or exceptions can be escalated. Sometimes in the whole inspection, some of the items are never ever counted. In such a scenario, you can run a report like this, which will, and you can also filter it by valuation or the price of that item itself, and kind of get to certain items that you might like to do a special inspection for. So from inspection perspective, there are many ways you can actually handle it. And you also would like to know how many items were manually adjusted, so that you learn about spillage, wastage, unaccounted items. All of that will allow you to find your efficiency of stores and all the controls that you have at a store level, or people who issue it but not associated with any work orders. Even that type of work orders can be, that type of item count can also be done, so that the overall idea here is to find inefficiencies in the storeroom and the procurement process, or in the issues and the way spares are handled. And all this can be done in the context of maintenance and reliability goals. So with that, Neil, I would like to open this for questions, and we can then go back to certain things that we may have missed.
All right, we have some questions coming here. So
okay.
How can I manage slow-moving items, and how can I bring inventory turn ratio without write-off materials?
It's a little difficult question. There are there are a lot of different things to go through. As far as slow-moving items are concerned, I think most companies we have seen is, once you identify and once you define what is a slow-moving item, then maybe we also have to look into the other factors related to reliability goals, or related to the value of the item itself. We then probably have to do further. Once you identify slow-moving items, then you may do further analysis, whether it is related to critical equipment, production associated with any production goals, or anything to do with downtime. So there may be some other criteria that you believe are important in understanding what to do with these slow-moving items. But once you do that, then it's a management decision whether you want to get rid of it or reduce the inventory of slow-moving items, and then maybe keep it bare minimum based on the past usage, etc. Sometimes the slow-moving analysis may not tell all the story. It may give you a wrong impression also, because if you have a fleet of assets which have been procured recently and they are in their early stages of the life cycle, then probably those items may not have been used. So you really have to take things into context. So you look at the slow moving, then look at all these other factors, and then determine whether these items need to be, you need to get rid of it, or you have to treat them as an obsolete item or not. So the next step of that slow moving item will, is tagging it into an obsolete item in some cases, depending on the situation. So I think the question, there was other part of the question. What was the other part? I'm sorry, I missed out on that.
Phil, how can I bring inventory turn ratio without write-off materials?
That's again, that goes back to the question whether what are the practices. We had some customers, just that was a business rule that once the spare is in the stock, after 3 years they will automatically write it off. From a book standpoint, from the P&L and balance sheet standpoint, from an accounting standpoint, but in reality, some of these assets are in use for 20 years, 15 years, depending on what that asset is. In such a situation, you might have different decisions from an accounting standpoint, and you might have a different decision from a maintenance and reliability standpoint. So it really, it's a little bit subjective answer, but if I were in that situation, I would look at what the maintenance and reliability related aspects are, and then determine how do I handle slow moving item and the items that are kind of sparsely used.
Sunil, there is one more question. How spares criticality is calculated? Is it same as equipment criticality?
I think it's very closely related to equipment criticality, but I think it is also, some items may not be directly critical, or they may not have been tagged or associated with a critical item because of various issues with data quality, that sometimes that information is not correctly documented. But the other way to look at it is if you had any emergency work orders which has any direct downtime associated with it, and all the items that were used in those emergency work orders can then be analyzed based on the historic usage and the risk associated with the stockouts. And if those are the items that are associated with the emergency work order, then you might treat it as a critical spare. So that's just one example, but there are other things to consider along with this. But an easy, simple way to do it is look at last 3 or 5 years of work orders, all emergency work orders associated with the downtime greater than 0, and then look at all the spares. When I say look at, data can be analyzed with all the spares associated with them, and then maybe that's your first cut of assigning it as a critical, and then look at it do further evaluation. I think we are up with the time.
That's right, Sunil. There are a lot of questions, but we'll definitely revert back with answers for those questions. Well, I'd like to thank everybody for their participation, and thank you so much for your time and information today.
Thank you very much. Thank you all.